In the previously, we solved all the problems of trigonometry. Now we are going to solve the problems of applications of trigonometry. So, what is the use of applications of trigonometry? In this chapter, we are going to learn where we are going to use the concept of trigonometry. So that is, the use of trigonometry is to calculate height of a tree, height of a tall objects, height of a tower. So similarly, the distance between the moon and the earth. So these are the applications of trigonometry. Now, in this chapter, we are going to apply this trigonometry concept and we are going to calculate the height of a tower, height of a building, height of a tree, all we are going to calculate. So before going to solve the problems of trigonometry, now we have to see some definitions. The first one is line of sight. Line of sight. A person is looking at an object, then the imaginary line joining the object and eye of the observer is called line of sight or ray of view. So, what is the meaning of it means? For example, here it is a tree. Okay, a person is on the ground. So, he was observing the tree. He was observing the tree. So, an imaginary line between person and the observation point is called line of sight. Line of sight. An imaginary line between the object and eye of the observer. Okay. The line between object and the observer person is called line of sight. This is the first definition. Definition number 2. Horizontal line. An imaginary line parallel to the earth surface and passing through the point of observation is called horizontal line. So, he is the observer. If you draw a line which is parallel to earth is called horizontal line. Horizontal line. An imaginary line which is parallel to earth and passing through the observation point is called horizontal line. Next, angle of elevation. If the line of sight is above the horizontal line, then the angle between them is called angle of elevation. So here, this is the horizontal line. If the line of sight is above the horizontal line, so here this is above the horizontal line, the angle between line of sight and horizontal line is called angle of elevation. Next, angle of depression. If the line of sight is below the horizontal line, for example, the line of sight is like this. So now, the person is observing below the horizontal line. So then, the angle formed between horizontal line and the line of sight is called angle of depression. So, these are the 4 basics we have to understand. First, what is the line of sight? Line of sight is nothing but an imaginary line between person and the object. An imaginary line between the person and the object is called line of sight. What is a horizontal line? The line which is parallel to the earth passing through observation point is called horizontal line. Or simply we can say the line which is parallel to earth is called horizontal line. So next is angle of elevation. Angle of elevation. So for example, this is the horizontal line. This is the horizontal line. This is the line of sight. This is the line of sight. The angle between these two is called angle of elevation. if the line of sight, this is a horizontal line, this is the line of sight. The line of sight is above the horizontal line. The angle between these two, horizontal line and line of sight, is called angle of elevation. For example, this is the horizontal line. Line of sight is below the horizontal line. This angle is called angle of depression. Angle of depression. Simple. Line of sight is above the horizontal line, it is called angle of elevation. If the line of sight is below the horizontal line, it is called angle of depression. So next we will solve the problem. This chapter, if you want to solve any problem, first we have to draw a rough sketch. First we have to read the information what he was given. According to that, we have to draw one rough sketch, rough diagram. From that diagram only we are going to solve these problems. Next you see here, a tower stands vertically on the ground from a point which is 15 meter away from the foot of the tower. The angle of elevation of the top of the tower is 45 degree. What is the height of the tower? So he was asking that find the height of a tower. Find the height of a tower. So first we will draw one rough sketch. A tower. So a tower stands vertically on the ground. Okay, this is a tower. Name the tower as AB. AB is a tower which stands vertically on the ground. From a point which is 15 meter away from the foot of the tower. So this is called foot of the tower. This is called the top of the tower. So what he was saying that from a point which is 15 meter away from the foot of the tower. So from this 15 meters away, the distance between foot of the tower and the observation point is nothing but 15 meter. The angle of elevation at the top of a tower. So a person is observing the top of a tower. So now the line of sight here is above the horizontal line. Therefore, it is called angle of elevation. So how much is the angle now? 45 degrees. Now what he was asking to find the height of a tower. This height we have to find. First, we write given statement. What he was given? Given angle of elevation that is theta is equal to 45 degree. The distance between foot of the tower and the observation point. That is equal to 15 meters. What we have to find? We have to find height of a tower. Height of a tower. So that is solution. Let the height of a tower equal to h. So this become now h. Now it is a right angle triangle. We have to use trigonometric ratios. We know that 6 trigonometric ratios. So to remember these trigonometric ratios, I given one shortcut OAO HHA. So this is the shortcut to remember 6 trigonometric ratios. So O by H means sine theta, A by H means cos, O by A means tan, reverse is cot, secant and cosecant. Next you see here. So now we have to find the height of a tower. This is the angle, so this become our opposite side. This become our adjacent side. This is our hypotenuse. So we know one angle. We have to find the opposite side. So first we know adjacent side. So we have to check that is there any relationship between opposite and adjacent. So from the 6 trigonometric ratios, opposite and adjacent relation that will be given by tan theta. So that is we know that tan theta is equal to opposite side by adjacent side. That is 45, 45 degree. Here the opposite is nothing but h. Adjacent is nothing but the 50. Tan 45 degree is nothing but 1. From the table we know tan 45 degree is nothing but 1. So now we do cross multiplication, that is h is equal to. Therefore, the height of a tower that is h is equal to 50 meters. This is the way we have to solve this question. Now we will see the second one. Question number 2. A tree breaks due to straw. The broken part bends so that top of the tree touches the ground by making 30-degree angle with the ground. The distance between the foot of the tree and the top of the tree on the ground is 6 meters. Find the height of the tree before falling down. So first we have to draw rough diagram for this given information. See here. This is a tree. Okay. This is a tree. So let it be some AB is the height of a tree. AB is the height. So now the tree was broken into two parts. So the broken part is touching the ground like this. So now A, B. Let it be some, the middle part is nothing but some C. Now the distance between this is the top of a tree and foot of a tree. The distance between top of a tree and the that touches on the ground is nothing but 6 meters. So now angle is given, that is 30 degree. Touches the ground by making an angle of 30 with the ground. That's why this is the 30 degree. So now what is asking? Find the total height of a tree before falling down. So now first we write the given. What he was given. Angle with the ground. Top of a tree with the ground is equal to 30 degree. The distance between top of a tree and foot of the tree is equal to 6 meters. We have to find the height of a tree before falling down. So we need to find the original height of a tree. So now you see here, the original height is nothing but AC plus BC. That will give us original height. Here to here we have to calculate first. Next B to C we have to calculate. If we add both, we will get the original height of a tree. So now we see here, in this triangle, this is the angle. So this become opposite side. This is our adjacent side. This is our hypotenuse. So first we have to calculate the opposite and as well as the hypotenuse also. So now solution. First we have to use the relationship between adjacent and opposite. Which value, which trigonometric ratio will give you opposite and adjacent relation? So opposite adjacent relation is nothing but tan. So that is, we know that tan theta is nothing but opposite by adjacent side. So here the angle is 30 degree. Opposite we don't know, that is AC. Adjacent is nothing but 6. Adjacent is nothing but 6. Tan 30 is nothing but 1 by root 3. So AC by 6. To cross multiplication, root 3 into AC is equal to 6. We are getting AC is nothing but 6 by root 3. So if you rationalize the denominator, multiply and divide with root 3. So you will get 6 root 3 by 3 into root 3 become 3. 3 ones are 3 twos are. So AC value we are getting 2 times root 3. 2 times root 3. This is the value of AC. So similarly, we are going to calculate the hypotenuse. So that is, we need to find a relation which will give you the hypotenuse. That is, opposite hypotenuse we can use, or we can use adjacent hypotenuse relation. So now, so I'm using sine theta. Sine theta is nothing but opposite by hypotenuse. That is sine 30 degree. Opposite is AC, hypotenuse is BC. Sine 30 is nothing but 1 by 2. AC value 2 times root 3 by BC. If you do cross multiplication, BC is equal to 2 into 2 times root 3. That will give you 4 root 3. So we got the value of BC also, that is 4 root 3. 4 root 3. So therefore, height of a tree before falling down, that is nothing but AC plus BC. AC plus BC. AC value is 2 times root 3. BC value is 4 times root 3. If we add these two, we are getting 6 times root 3. So this will give you the height of a tree before falling down. So if you substitute the value of root 3, that is 1.732. So multiply with 6. 6 2s are 12. 6 3s are 18. 18 plus 1 19. 6 7s are 42. 42 plus 1 43. 6 1s are 6. This is 6 plus 4 is nothing but 10. The point after 3 digits. So 10.392 meters.